So it is a start for the session about API gateways, proxies, and different cloud connectivity patterns for developers. Let's start with small premise. And in this talk, we're going to be talking a lot about the microservices. And when you start develop these microservices, it's small is nice. It's nice. It does exactly what you were planning it to do. And after that, that's the whole purpose of microservice. Just do part of the job that was the part of the job that needs to be doing something. It's microservice. Over the time, your microservice needs to communicate to other microservices and adding some additional functionality that might not be part of the initial MVP, initial business task this microservice needs to be doing. Because apart from doing the business task that the microservice was designed to do, there's always day two responsibilities. Day two responsibilities are security, connectivity, access control, authorization, authentication, encryption of the traffic, and so far and so on. Over the time, you're adding those functionalities into your microservices and everything is growing. Your microservices is becoming a big thing, and stuff that you do in this microservice already far beyond that you initially designed to. The service becomes a very dark place, and maybe even some dead code. And if you want to figure out what is going on there, and you might find yourself like a Charlie's Day character from It Always Sunny in Philadelphia. It's crazy. You don't understand what is going on. And at some point, you need to make a decision. If you keep adding these pieces of functionality that might not be 100% moving some of the business use case, but rather than you adding more and more infrastructure. So today I'm going to be talking about different communication patterns for these small services, and these microservices are arranged in a mesh, which is also foreshadowing things that we're going to be talking about. My name is Viktor Gamov. I work as a principal developer advocate at a company called Kong, and in Kong we develop tools and solutions for developers so they can build their next big thing. And we would like to have tools that allow them to build a cloud connectivity in their apps. I also a co-author of upcoming Manning book. I was told that it will go to printer next week. So to celebrate this, there would be some discount. We're going to be talking about Kafka as well. We're going to be talking about Gateway. We're going to be talking about Service Mesh. And at the end, also we'll talk a little bit about Kafka. I spent some time in my professional career working on Kafka, and it says a release fall 2021. The developers are really bad on estimating deadlines. So, but you can use the code Kafka A35 and you can get 35% off on any edition, electronic or print. So we'll start with something that many of you probably heard at least, but usually it's something that meets every request. And as a developer, you need to understand like what is this and how you can apply this pattern essentially. But what is API gateway anyway? So let's get a quick recap. Some people can say, well, it's something that sits in between of your application and your client. Essentially, API gateway is architecture before it becomes a software, before it becomes the component of your system. It's actually a architectural pattern. API gateway is something that sits in between. It's additional network hub that proxies or transfer requests that coming from your client that goes into your upstream service, the API that your client wants to access. And you can do interesting things around this API gateway fella. Some of you might say, wait, it just looks like proxy, or like, to be precise, it's more like reverse proxy because it goes in other direction. And as the Barry Allen said from Justice League, it feels like a little bit of oversimplification of the thing. So yes, it's additional network hop that it looks like a proxy. However, there's a couple things where this architectural pattern and software that implements this can help solve. I'll start with first pattern, service connectivity, the connectivity between your client that will try to reach your application and connectivity between your upstream service that you want to serve through this API gateway. With this simple use case with service connectivity, you want to provide the external access to some sort of service, your piece of functionality. You developing something that you will be selling in future. So you're developing something that will be available as API, or some of the service that will be exposed as API. We'll start with some simple things that, because we, in these days, we're working on application level protocols, or also known as level 7 protocols. Level 7 will correspond to level 7 in network model, where protocols like HTTP and protocols like HTTPS, gRPC will sit there. So those traffic policies we're going to be talking about some of the rules, how this traffic can be, how this type of traffic will work in. And when the client interacts with our API gateway, we can enforce different policies in order to add additional functionality. In some cases, this API gateway also can be can do things like load balancing, or like if you're this API, it would be instance of one API, and you need to spread the load between different API calls that your client does. API gateway can load this balance. In other things around enforcing some of the traffic shaping, or things that your application might not be designed, but you need to have certain rules to enforce in order this application, in order this the API thing will be available and will be compliant with certain requests. If you remember, if you are like a movie buff like myself, Jean-Luc Picard was the captain of USS Enterprise, and he will represent our service, like a service that can do certain things. He managed his Enterprise, the space vessel, and this is his role. And in our case, it might be some sort of like a web service that will be accessible through some sort of API. Like, think about this, we designed some super cool system that will be do image recognition, and it will be available through API. We designed this, we developed this, we deploy this, and after that, when we ready to we deploy this for testing, and when we're ready to ship this to production, some of the operations concerned might arrive. So how you would enable some of the say load balancing, right? So you put the proxy on top of it. How you would implement rate limiting? It's easy. You can if you in a Java world, for example, you can use any available framework that allows you to implement, like either it's going to be Bucket4J or Resilient4J, that allow you to implement some sort of rate limiting logic into your application. Or you need to support different versions of this API. You need to do version 1 and version 2, because when you start implementing this, you provided access to some of the beta version of this API, and a lot of users start using this. Now, when you deploy this to production, all of a sudden you need to deal with the new version API, and maybe you need to support 2 versions of this API. So all these things needs to be somehow implemented. And who will implement those? That's the question. And this is neat part, where you're using this the API gateway pattern, you can offload these functionalities into pieces of infrastructure instead of putting this inside your application code. Again, if we will bring in back Jean-Luc Picard, at some point of his professional career, he received some of the augmentations that automatically make him, he still performs his biological functions, but also he received these automatic augmentations for his service. So with the ability to enable those additional pieces of functionality without you explicitly code this, without explicitly sitting there and writing apps, it's good that if we, for example, okay, we can say, yeah, Victor, we can implement everything. I understand you, like we in the Java world. However, with microservices and the approach of building the systems with the smaller teams, we enable those teams use whatever language they like. If they want to use Java, they can use Java. If they want to use Go, they can use Go. But if they will try to implement all these pieces of functionality as a part of their application, so in this case, they need to make sure that the framework that they will be using will support this piece of functionality. And for that matter, the API gateway provides the entrance, basically admits all client requests, putting some of the additional pieces of functionality, including rate limiting, including load balancing, logging, capturing some metrics, do rate limiting, and so far and so on, to provide you access to any type of service that's available outside world. Another example here, there might be, you develop your service that will be using some protocol like gRPC, but to consume this service, you need to make sure that your clients also support gRPC. With the capabilities that are available on the API gateway side of things, you can provide some sort of proxy functionality that will transform your gRPC call on the backend, on your upstream service, with REST that will be exposed to client. That's also possible. It also can be done automatically. So now the thing's getting slightly different and bigger when we developed our API as a product. So we start getting more and more APIs. Remember, let me show you. Remember this, we started with one service. We started with something small. And after that, we actually start growing our system. We're adding more services. But for the user, this needs to be something straightforward. You don't need to enforce your internal architecture to external clients. So API Gateway allows you to perform some sort of aggregation of APIs, and based on the different endpoints that we have exposed to the clients, those would deal with the different pieces of your infrastructure. If you go in /billing, it might be redirecting you to a billing service. If you go to /orders, it would be some another service. It's going to be another service. But think about this, like when I said the client, this client not necessarily needs to be a client, external client, the people who interact with your product. By client, it also can be another department who wants to use your microservice. And this is also applicable for situation when you develop the product internally. So API as a product can be also internal thing. Similar thing like a private cloud, right? So the private cloud is something that one team developed and provide as a service to another team. Same thing here. So some of the teams, they develop APIs in the organization and they communicate through those APIs. And those APIs provided as a product. So in one case, one of the clients can access this API, and API Gateway can provide the ways how some of the corporate policies can be enforced. Once this become something that the people are onboarded with, so we start develop like a platform that serves needs of many, there is need for providing full API management lifecycle. And this is where the API gateway becomes something bigger. It becomes the part of API management platform that allows you to perform full cycle of different application needs, starting from the point where we design our API. Usually these days, Open API standard is the way how the people using this kind of the specification and agree upon the contract of this. Once you agree about this contract, people just like, okay, so we done, we're good. So now let's build our apps. And it's good that if one of the teams will provide access to those pieces of functionality quickly, they may be, coding faster, they're developing things faster, or they already have something, but they need to change a little bit. And after that, this old API will be compliant with the new specification. However, in many cases, it's not true. It's not the case because it takes time to say backend developers to develop backend and front-end developers to develop front-end pieces. So this is where the mocking side of things comes into play. What about take this part of specification, or rather, where is it? Yeah. So we will take the this guy. We'll take this part of specification and turn it into living service. However, it will have some mock responses, maybe predefined responses. Or if we design this response, we'll return 200 or 503, 404, this type of stuff. So you can start building your apps. And API Gateway can actually provide the ways how you can mock this type of things, including the testing phase as well. So how you would test your APIs, how you would test your specification. Next thing is that support in a runtime. Things that I mentioned in the when I was talking about this one. So API is a product. Different clients will try to reach your API, and also the most important, the biggest problem that many organizations are facing is discovery. They don't know which API to call, with which parameters. Today, like literally today, we had this meeting with use case breakdown with one of our customers, and before they onboarded with some of the tools that I will be talking about in a few seconds, the biggest problem for them was discover APIs, discover what's available. So the new team start developing some of the pieces of functionality that will be helping to drive business. They didn't know if there's something is available, some API is already available, or if it's available, but in a what form. So the API Gateway has opportunity to not only take this specification that was the part of design, that was something that we designed here on design phase, but also we can generate a developer portal that will include all information about what API available, documentation, some of the snippets that the people can run to test this API. How to maybe even generate some SDKs based on this API. You say there's API, there's backend, and you want to develop a iOS client. It would be cool if you go in there in this portal and get SDK that will be serving some of the underlying needs. So you don't need to implement like some of the retries logic or retrieval or marshalling of the JSON, turning it into some object that you will be manipulating in your application code. So those parts of onboarding are important here as well. And now, when we're successfully running this in production, things to understand how this API is used, maybe implementing some sort of monetization logic to figure out, okay, so this API was used by this and this client, how we can understand, like we can understand and we can start like charging this, or when I say charging, it not necessarily needs to be kind of like some of the monetary value. Maybe there would be some of the heavy consumers. You need to put some of the rate limiting on top of this, so they will not overwhelm your API, so you continue to serve this to other things. The monitoring to see if there are any errors and who bring this error. So this API gateway fella, this central thing, becoming something much more than simple proxy. So remember, in the very beginning, we started with a simple idea of just, okay, so we're going to start with something that will would be another network hub in our application. And after certain explorations and putting some of the more information and understanding more information about this API gateway, we came into understanding of one, that the API gateway can be full lifecycle management system that allows you to do things. But let's talk about next things. When I said gateway admits, it's essentially something or someone who invites you to join, right? Think about this as a host of the party. Host meets you, checks your credentials. That's your authentication, authorization metaphor. Checks your credentials and allows you to enter system. And it would be weird, or maybe not. So you might have so the next thing that you need to go, you go into the party, you meet this the host who invites you, and you go into party. And after that, in order to figure out what is going on there, in order to understand where you should go, you can meet other hosts, maybe other proxies. So internally there could be like multiple different proxies. But what if we can take this proxy functionality and provide the general knowledge about what is going on this party through different guests who can after that propagate this information to you. Think about this like you join the party, and after that there would be someone who will explain you everything. So you already came into party and someone will greet you and say, hey, so welcome to this party. You can find this stuff is there, the restroom is there, the banquet, the table, and or this like a open table, everything would be available there, so you know how to do this. So with this, we will have some sort of centralized control that allows to guests to perform their duties as guests in the way how they want to do it. And there would be no need to ask permission every time. You're already there, and you will given permission to do so. So this is where we're going into the place that I like to demonstrate with another Star Trek reference. So in this case, we talk about our Borg collective. So remember, so with these augmentations that the proxy or this API gateway provided to our service, other services got the same augmentations. Now, the global control and how those services are communicated to each other, they can communicate directly. They don't necessarily need to go through some centralized service discovery mechanism. They just know there is a convention how they can communicate. And they don't need to have a central place to ask how to communicate to each other. So in this case, the services are relatively independent, but they still have certain augmentations that I was talking about, all these things around traffic management, traffic shaping, and so far and so on. And they will form some sort of thing that will be performed as one whole thing. in Star Trek movies, we were introduced to concept of Borg Queen, and the Borg Queen was the entity that can control and have a centralized brain of the operation. So essentially, this is a fantastic illustration of concept of service mesh. With service mesh, we do have. Let me point out here. So with the service mesh, we have control plane. That's our brain of operation. This is something that knows a little bit more about everything, and the information persisted somewhere. This is our Borg Queen. This is our Borg Queen crown, some sort of crown. And this is something that controls all the things. And each individual component of the service mesh, it's our Borg drones. As you can see here, this is our service. This is our Jean-Luc Picard over here. So let me, this is our Jean-Luc Picard here. Or some others who get into a Borg assimilation process. And this is our augmentations. This is our augmentations. This is something that allows us to perform some extra work without interfering with our service. This is service mesh architecture in a nutshell. We have a control plane that has some information about the traffic policies and how these services will communicate. We have our data plane. This is something that is a small proxy, small gateway that sits next to your service and provides you ways how you can communicate with other services, or you can communicate with Borg Queen. And most importantly, that our service stays as is. We don't need to do any modification. And it turns out with this architecture, with the additional proxies that will sit next to our service, and the way how it will be implemented in the real world, I'll talk in a few minutes. We can do multiple interesting things. We can start by defining some of the more granular traffic rules between what service can access what service. In this case, we can enforce different entitlements. So not necessarily all the services needs to have access to all the services. We can enforce things like traffic level encryption. Our services will encrypt the traffic communication between each other. And this thing, most importantly, can be automated and automatically updating certificates when the certificate will expire after a certain time. So this is our Borg ship that we have. Next thing with the with the Borg, we might have multiple different cubes, and those different cubes can also communicate through this. And the service mesh allows us to create so-called multi-zone mesh. So we can deploy our services in multiple different data centers, and we can span one mesh across multiple, in this case, I do have multiple zones and multiple clusters. And interesting here that some of the services can run in JVMs. Some of the services can run in clusters like Kubernetes. Some of the services like, for example, I would just do bare metal, right? Bare metal. So, and throughout connectivity, throughout the connection between multiple control planes, we will be able to do this multi-zone mesh. Again, to bring you to this picture, this is exactly what we're trying to do with the multi-zone. This is our AWS, this is our GCP, and this is our Azure. So those meshes are running Those meshes are running in the different data centers or different cloud providers, but there would be one common brain that will connect them. That's the service mesh. Now, you can ask, okay, so it's all good and nice and very interesting, but like which one to choose? Like which is which? Sometimes when you start reading things in internet, the people talking about, okay, so gateway is for north-south traffic, and the service mesh is for east-west or west-east traffic. What does it even mean? Like, why we need to, like, it's probably natural for US people. I don't know. I noticed that US people are very good oriented in environment. They know where's the north. They know where's east, so that's why, oh, go to east, go to west. I don't understand this. Like, I'm geographically impaired, and I cannot figure out this without compass or GPS or whatnot. So I need to have like a simple instructions. I need to have instruction that says, okay, in case of this, go with this. In case of this, go left, go right, and so far and so on. So that's why I do have this diagram that decision diagram that I want you to walk through. Now, so first of all, which one to choose and where to choose. So we're starting with on the top. We're developing API or service, and we are planning to offer this as a service, meaning that there would be clients. There would be clients in the sense of customers, or would be the clients in the sense of your application clients. So yes, if we're providing this as a product, it would be consumed within organization or outside. Yes, it's going to be consumed on outside. So in this case, there would be a gateway that sits on the edge. And the why I'm distinguishing two things here is because there might be different requirements from perspective of compliance, internal security, and service level agreement that you have with your customers. Because if you offering this API internally, you might have a less strict requirements on where it needs to be deployed or how it needs to be protected. There's how it's called, like the division or whole new ideas around the concept of zero trust and how the services need to trust each other. I'm not going to cover it today, but in general idea of this is that like nothing is secure and you need to always be paranoid about security and paranoid about accessing certain things. And that's why the edge and your internal API gateway, they might have a different requirements. So, for example, for external, for edge gateway, you might have a SSL termination on the edge. So all the traffic that comes into the system needs to go through TLS or HTTPS. But internally, it not necessarily needs to be encrypted. So that's why distinction here. Now, this is something that's very important that I haven't spoke yet. There's a concept called a sidecar. It's another architectural pattern. It means that there's something that runs next to your application and will provide certain pieces of functionalities. So think about the sidecar as have you ever seen the bike with sidecar? So it's essentially similar concept that came popularized through the Kubernetes. This architectural pattern is popularized in Kubernetes world. Unit of deployment in Kubernetes world is pod. Pod is not a container. It can contain one container or it can contain multiple containers. When you have multiple containers that belongs to the same pod, those containers actually sharing some of the common things, like sharing network interface. So those two containers, if they are sitting inside one pod, they are sharing localhost. They can talk to each other through localhost. And also they sharing, I think they might share some of the file system bits. But in our case, we're more interested in localhost side of things. Now, when they can talk to each other through localhost, one container can be served as a proxy. So all the traffic that goes into one container will go through this proxy. So that's why this sidecar, in reality, many implementations of service mesh use this project called Envoy. It's the proxy written in C++, really tiny and super fast, battle tested and stuff like that. And it can be used by, it has a protocol where the configuration of this proxy can be changed in a runtime. So that's why it can be used as your data plane. If we, if we look at this slide, this is where we're sitting. This is where our Envoy is sitting. It's our data plane. So the control plane sends all the information to control this to this data plane, and can change configuration in runtime. So during the startup of this pod, one of the pods in each container, it's third one container that can run. It can modify some of the IP table rules. So all the traffic that all happens in this pod will go through this sidecar container. So that's why it's one of the rules where if you can afford this, if you can do this in your deployment, if your choice is yes, so you need to select if you do part of, if you're starting your own if you're starting your own work cube, or you creating something as a part of another cube. So you will either join existing mesh or creating new service mesh. If for some reasons you cannot, maybe it's operationally it's not possible, or maybe your organization is not ready to go this route, it's okay. The API gateway can still be the part of this picture. So essentially, we're going into this route, like very similar route here. One way or another, you will need to have some sort of gateway, some sort of proxy. But it really depends on how you want to deploy it. If you deploy this in environments where you can support sidecars, you go with service mesh. If you doing something that will be externalized and available to outside world, you going through the route of thinking about this. I mentioned Kafka, not casually mentioned Kafka in the very beginning, but hey, you can say, Victor, what if for my application connectivity, I use Kafka? How this, like, or for that matter, like event-driven approach. I want to use event-driven approach. How this thing that you were just talking about will change the approach, how you're doing this. And every time when we talk about Kafka, I like to indulge myself by bringing some of the data aware. And when I say data, I mean lieutenant data, data-aware connectivity. A few years ago, Gwen Shapira, she's the engineering manager in Confluent. She's helping to build a Confluent Cloud. So she did the talk when she were talking about how Kafka, similar or different from service meshes and how the stuff can be, how engineers need to think about this. And we started this to how the services will communicate. So essentially, this is how the services now communicate in our case, right? So we do have one service that calling another service, and there's another service that calling two services in order to get a response. That's what essentially the service mesh does. Essentially, we just need to have like small proxies. So they need to call through the proxies. The communication needs to happen through that proxy and so far and so on. And this is our service S1, S2, S3. So what Kafka can do in this case, it can save communication or represent communication between system in the form of log. Not this type of log. It's not log4j for that matter, but rather than in something that will be ordered in time and would be persisted. So whole history of things that happen in the system will be revolve around concept of immutable transactional log. And Kafka will be providing the way where the information about the services will be stored. So there will be no direct communication between the systems. In this case, you change the way how you're thinking about the services. So services are not talking to each other in using verbs to communicate and passing around entities, like you sending this part of request and response, but rather you sending events that will represent something that happened in the system. And another service, which would be interesting in having state, will be able to create desired state for itself. So this topic is slightly off chart or like a little bit off from today's conversation, but I just wanted to bring this up that it's also possible to implement this pattern even with service mesh and API gateway. And some of the patterns that you can use in your application design. So when you start building event-driven systems, when you're going away from the passing around entities and start saying events, the way how you can think about your interactions or your interactions between your microservices, the approach will change, and you will communicate through events. And in order to services to understand those events, you will start talking to them through. There's a two type of patterns that are available. Either it's going to be one event orchestration or event choreography. So when you were talking about event orchestration, that's some pattern that you might remember from the past, from the times where you have an enterprise service bus. And enterprise service bus might have some logic in terms of routing events based on the type of events, based on the headers, and so far and so on. This approach is, first of all, it has a single point of failure, right? So your logic of the system will depend on enterprise service bus and the way how you will update the code and in the service bus and on this logic. Another approach that would be more suitable for independent in the microservices world, it's actually event collaboration or choreography, where each event or which each system knows on which event they need to react. There would be one topic with all the orders, and only if the new order will be placed in the order service, order service will react. And based on some of the stuff that order service will do, payment service will be invoked. So order service will prepare the order, and after that, we'll send this to, say, order was validated and it's ready to be sent to payment gateway. Sorry for naming is hard in the world of IT. So when I say this gateway, it's not necessarily means to API gateway. It's just like payment gateway, something like some API that you need to invoke. And so far and so on. So in this case, payment service doesn't need to know anything beyond itself. It only knows that if there would be an order validated event, only this time the payment service will be triggered. So in this case, we still have full history of events that store somewhere in our event store. In the particular case, we'll store this in Kafka. And based on the things that happened in the real life, this system will react, the particular service will react. So the pattern, if you want to go a little bit deeper understanding this, in developer.confluent.io, there is a patterns library where you can learn a bit about this. Another pattern that fits well into topic of my conversation today, it's where you can use gateway and mesh together. So your internal architecture will be served through the communication and entitlements will be based on service mesh, and your user activity. It can be user activity, or it can be in other services. We'll try to involve. We'll go through gateway. That's gateway. So this is our API gateway. And in Conk, we built also like API gateway and the service mesh. The service mesh that I was talking about, it's called Kuma. And this is where my application is running. So services will interact through gateway. Internally, application will interact through service mesh. Things around security, internal security, or like enabling MTLS between service, providing some of the traffic policies between different microservices and see how they will be interacting with each other. Or even dealing with the services like Kafka, or connecting to services like Kafka, or connecting to databases and so forth and so on, also can be handled by a service mesh. Service mesh, gateway. And in order to connect to worlds, there's another pattern. And the funny story here is that it's called event gateway, that allows us to bridge event-driven approach and request response approach. So essentially, gateway can expose through the in case of Conk, there would be some plugin that needs to be enabled here. But your application, it's a REST application, will try to, or REST or gRPC or whatever. This application will try to invoke this request on API side of on API gateway side of things, and the gateway will publish this as a stream of events. So this is how you can use gateway in order to like from this particular example, in order to bring the event somehow. So the gateway also can be here, that will be submitting those events, order submit event. So everything would be work very close together in order to serve this. 3 things that you need to remember from today's talk. So gateway admits, meaning that a gateway brings the traffic into your system. You can put additional functionality to this the doorkeeper or doorman, door person, to do some additional things. Maybe do SSL termination. Maybe do rate limiting in order, like you have a bouncer, right? That are not allowed to go as many people as you have in your system. So think about this way. Mesh, on the other side, connects the services, provides the communication patterns between different application, or maybe provides like a very fine-grained communication between different services. Mesh connects. And no pun intended, but Kafka stream. So in this case, like stream of events and the way how the Kafka can present here as one of the communication protocols. When we're talking about gateway and APIs, not necessarily this API would be 100% translated to request response API. A Kafka API becomes very ambiguous from perspective of how it can be used, and from perspective of actual implementation. There is actually multiple different implementation of Kafka API that allows to different clients to talk to. So there is on-prem implementation, there's a cloud, there's managed implementation, different implementation of different languages, and so far and so on. So you can use this pattern still, but you need to figure out which way you want to go. Gateway can admit your events through event gateway pattern. Remember from this one. And I want to as a last slide, I want to tell you, if you want to learn more, join me bi-weekly. I do live streams, or we call it Kong Builders, where I'm breaking down different demos. I'm breaking down different patterns, tools, Kubernetes and service meshes, a lot of things. So subscribe to our YouTube channel and join our community at the konghq.com/community. We have a discuss forum with your questions, and hope I will see many of you there. My name is Viktor Gamov, and as always, have a nice day.